Luca Congedo and you're watching From QGIS to Remote Sensing. This video tutorial is about the land cover signature classification, a new algorithm which allows for the classification of land cover using spectral signature ranges defined in the spectral signature plot. So the first step is to create the band set. In this tutorial we are going to use the sample dataset, which is a subset of a Sentinel-2 image. So extracting the image here, we can see all the bands that are already converted to reflectance. In QGIS we can create the band set using this button here. Open the bands, clicking this button and selecting the Sentinel-2 bands. Here we have the bands from 2 to 12. So bands are loaded in QGIS and added to the band set. So now we need to sort the band name in the correct order. In particular, paying attention to band 8A. Then we set the central wavelength here from the quick wavelength menu. Now we can see that the band set is defined as input image, and we can display the color composite. And now we are going to create the ROIs for these four land cover classes: water, built-up, vegetation and bare soil. So first we need to create the training input file. So clicking this button and define a name for the training input file, for instance training. And click save. And the training input file, the path to the training input file is displayed here. Now we're going to collect the ROIs from the image. We can, for instance, create a first ROI here over the lake for the class water. We can use these buttons for enhancing the stretching of the image. We can also change the RGB color composite here, for instance the color composite 732, so we can better identify the materials at the ground. And we can draw the first ROI using this button for drawing a ROI manually. So here it is the polygon. We can set the macro class information water, class information lake, and click this button to save the ROI to the signature list. And with a double click we can also change the color of the class here. So now we're going to create a second ROI for the class built-up. So using this button here we can activate the ROI pointer and create a ROI with the region growing algorithm. Particularly we can increase the distance value here and click this button redo to create a larger ROI. Then we can save the ROI, changing the macro class ID and macro class information, built up, and class information, built up 1, and click save. So again we change the color of this ROI. And now we are going to create a third ROI for the class vegetation here. you can see clicking with the region growing algorithm, we can show and hide the ROI with this button. Again, we change the distance value and redo the ROI. And then we can save the ROI to the ROI signature list, changing the macroclass ID, the macroclass information vegetation, and the class information trees. And click Save. Changing again the colors of the ROI. And now we are going to create a ROI for the class bare soil. We can see here the very low values of NDVI with the cursor here. So we can click and create a new ROI for the class bare soil. So changing the macroclass ID, the macroclass information, and the class information, and cultivated land. And click Save. Changing again the color for the class bare soil. So now we have 4 ROIs. We can double click on the name of the ROI to zoom directly in the map to the ROI, to the saved ROI. So now that we have collected enough ROIs, we can see the spectral signatures corresponding to these ROIs. So click this button, and the highlighted ROIs are added to the spectral signature plot. We can see here the plot of the 4 spectral signatures. We can of course display, show and hide one or more spectral signatures in the plot. This plot is very useful for showing the similarity between spectral signatures. We can use this checkbox to show and hide the band lines and the grid, and use this checkbox to show and hide the value range of each spectral signature. You can see here in this table the minimum and maximum value for each band, which represents the value range of each signature. It is very important because in this classification algorithm that we are going to use, we are going to classify pixels according to these values. So we can change and edit these values manually. For instance, here changing the value 0.08. We can also use these buttons for automatic thresholds, so we can change the values automatically. So for instance, here I'm going to set 0.8, so you can see here exaggerated this value. If I click this button min-max, the minimum and maximum values of these spectral signatures are automatically set to the minimum and maximum of the ROI. And similarly, if we set here this sigma times 3, for instance, we are going to set the minimum and maximum values according to the standard deviation for each band. So for instance, here we have 4 times the standard deviation, and again I set the minimum and maximum values for this spectral signature. So we can concentrate on the water spectral signature. We can change these values. We can see that we have created this ROI here in the lake, so changing the core composite. In particular, if we use the class ID and check this checkbox Use LCS, we are going to use the line cover signature classification, which is a particular algorithm which classifies pixels that belong to a certain spectral range. So only spectral signatures that fall completely inside a spectral range are classified. So we can see, for instance, here a classification preview using this button. We can increase the size of the preview and click Redo. Okay, so now we have classified this area. We can see that there are black pixels that are unclassified pixels here. This means that those pixels, spectral signatures of those pixels, are falling outside the spectral range. So we can use this button here to activate a pointer which allows to click on the pixel of the map and increase the spectral range according to the pixels that we are clicking. So, for instance here, and the spectral range is automatically increased and changed according to the spectral signatures of these pixels. So if we click the button Redo, we can see that some of these pixels, black pixels that were unclassified, are now classified as water. We can click again this button here and click on other pixels, unclassified pixels, to include these spectral signatures. And again, if we redo the classification preview, we can see that these pixels are now classified. And the spectral range is modified according to these spectral signatures. So now we can see that there is an area, black area, of unclassified pixels here. We can create a ROI, a region of interest, over this area. Here I'm setting the transparency of the preview. So here I'm drawing this ROI, and we can use this ROI to modify the spectral range so that these pixels will be classified. So highlighting this spectral signature in the plot, I click this button from ROI, and as you can see, the spectral range and the spectral signature plot is changed according to the pixels. We can use this button to undo this change. But I'm going to click again from ROI so that we are extending the spectral signatures, including these signatures. These pixels. And if I click this button, Redo, you can see that this black area is now classified as water. You can see there are still a few pixels here unclassified. And we can create a large ROI here to select all these pixels, all these unclassified pixels, and try to extend the spectral signatures of water to include these pixels. So click here from ROI. If we redo the preview, we can see that now most pixels have been classified as water. There are still a few pixels unclassified that we can select individually using the button. and we can refine the signatures clicking on these pixels. So here we have used this checkbox plus for extending the spectral signature to the spectral signature of pixels. If we click this minus checkbox, we can do the opposite. So if we create a ROI here, for instance, here in this area, we can reduce the spectral signature range according to this ROI, for instance. So click this button, and we can see that the spectral signature range has been reduced according to these pixels. And if we redo the preview, we can see here that most pixels are unclassified according to this spectral range. So of course we undo this threshold. We can extend or reduce the spectral signature range using this checkbox. Now we are going to compare two spectral signatures, built up and bare soil. We can see here that these spectral signatures are very similar and the spectral range is overlapping. You can see here these two spectral signatures are highlighted in orange in the signatures list table. Also, you can see in this column color that the overlap macroclass ID and class ID of the overlapping spectral signatures is highlighted. We can see, for instance, that the bare soil overlapping the macroclass ID and class ID 2, which is built up, and vice versa. So now I'm going to change the color of these spectral signatures just for clarity. And here we can see that these spectral signatures are very similar and have an overlapping area here. This overlapping area means that pixels falling inside this overlapping region could be classified both as built up or as bare soil. So for instance, if we click here, redo preview, we can see here these gray pixels. Here, these are overlapping pixels, which are pixels falling inside this overlapping region between these two spectral signatures, built up and bare soil. So for instance, if we uncheck cultivated land, we can see here the classification of built up. And if we uncheck built up, we can see that these pixels are classified as bare soil. So here we need to remove these overlapping pixels and change the spectral ranges in order to remove the overlapping pixels and classify those pixels in just one lane cover class. So for instance, we could edit these minimum and maximum values manually or using these buttons. We can also use this button to change the value inside the spectral signature plot. So for instance, we highlight this spectral signature bare soil. If we zoom inside the plot, you can see here the overlapping region in the band 12 of Sentinel to band 12, and here we can reduce the spectral range of the spectral signature bare soil in order to remove the overlapping region. So click this button and then click inside the plot here. Now I've clicked, as you can see, the spectral signatures are no longer highlighted in orange because they are not totally overlapping. As you can see, in this band 12 there is no overlap. So now these pixels can be identified, and if we click redo the preview, we can see here that these pixels are no longer classified as overlapping pixels, but classified as built up, because we have removed the overlapping region. So generally it's better to remove these overlapping regions. We can now select another area, for instance here, in these buildings, the airport. If we click the button for region drawing and then right click in the map, we can see the spectral signature of the pixel. You can see here the clicked pixels. This is the spectral signature of the pixel that I've clicked. You can click another pixel now, and here another spectral signature. So this is useful to compare spectral signatures of pixels with spectral signature ranges. You can see, for instance, here that these spectral signatures are not included in the spectral signature range of built up. So I'm going to remove these pixels from the plot, and I'm going to create a ROI here. In ROI creation there is an option for automatically creating the plot of ROIs, of temporary ROIs. So if we click automatic plot here and create a ROI here, you can see that the plot of this temporary ROI is automatically calculated and displayed in the plot here. This is the plot of this temporary ROI. We could, for instance, highlight the built-up ROI and click this button to extend the spectral signature range of the built-up. As you can see here, now it is included. All the spectral signatures of pixels in this ROI are included in the spectral signature range. And if we create a preview here, you can see the classification of built-up. Now I undo this previous extension of the spectral signature range, and I'm going to create a new ROI here for built up using this ROI. So for instance here, built up 2, and click save. So now we have another ROI, and if we click the redo button, we can see here that this area is classified as built up 2. So after the creation of several ROIs, saving several ROIs in the ROI signatures list, here I created a few dozens, and if we go to the classification algorithm and check macroclass ID, so we use the macroclass ID, the code of the macroclass, and if we create a preview here, we can see the result of the classification. And in particular, if we zoom inside this preview using this button here, if we zoom over this built-up area, we can see that there are a few pixels classified as overlapping pixels, and there are also unclassified pixels, these black pixels here. So if we now display the spectral signatures of these ROIs, We can see here that there are a few overlapping spectral signatures. For instance, these built-up and vegetation signatures. And of course, we can use the tools for changing and editing the spectral signatures range. In particular, this button here allows to edit directly the spectral signature thresholds, the LC signature threshold here, which is the list of all the spectral signatures listed in the ROI signature list, as you can see here. And we have the same tools that we have seen in the spectral signature plot, so the minimum and maximum button, the standard deviation button. For instance, here we click, we can reduce the spectral signature range. We have also the tools for extending and reducing the spectral signature range, as we have seen in the spectral signature plot. So after the creation and editing of the spectral signature ranges, we can perform the classification of the whole image, checking the use of the macroclass ID. We can go to the classification output tab and click this button, Run. Select the output name, for instance classification, and click Save. So after the calculation, we have here the lane cover classification of the whole image. We can see that there are still a few pixels unclassified and other pixels classified as overlapping pixels. We can also use an additional algorithm if we check this box algorithm here. We can use an additional algorithm to classify also the unclassified pixels and the overlapping pixels. So we can select here the algorithm, so for instance the minimum distance, and click in the classification output Run. So we can create the second classification. And in this case, after calculation, we can see that we have all the pixels classified. Here there are no overlapping pixels. Here, as you can see, the overlapping and unclassified pixels of the previous classification are now classified according to the additional algorithm. But we have also these unclassified pixels because I have created a few ROIs with the special macroclass ID 0, which is a macroclass ID for masking pixels, and I use these ROIs to mask clouds and shadows. As you can see here, these clouds are now masked and unclassified. But all the other pixels are classified according to the additional algorithm. If we check this option only overlap, we are going to use the additional algorithm only for the overlapping pixels. So we are going to classify overlapping pixels according to minimum distance, but we are going to leave unclassified the other pixels. So if we go to classification output and click Run, we can create a third classification. This time we are going to classify only overlapping pixels. As you can see here, the overlapping pixels of the previous classification are now classified according to the minimum distance algorithm. So here we have classified the whole image. This length cover signature classification that I have described in this tutorial is particularly useful for classifying just one length cover class. So if we check only the rows in the row signature list belonging to the macro class built up here, and if we create a classification using only these rows, so click here, run, and create a classification only of the built-up class. We can see here that we have classified only these pixels, only belonging to built-up here, and all the other pixels belonging to other classes are left unclassified. If we display the spectral signature plot of these spectral signatures of built-up, we can see here that we have several spectral signature ranges that are overlapping, but these are belonging to the same macro class. So if we, for instance, check here in use class ID, you can see that these spectral signatures are highlighted as overlapping, but if we check use macro class ID, these spectral signatures are no longer highlighted as overlapping, so we can create a complex set of spectral ranges that can be used to define very precise spectral ranges for the classification of a specific length cover class, so for instance built-up. We have completed this tutorial, so please join the Facebook group and the Google Plus community. And please also contribute to the translation of the user manual to your language. Thank you for watching.